Okay, so today's on vectors. So let's first off, if you haven't had these before, let's talk about what vectors are. And so I guess first off, they're used to represent mathematically quantities that have both magnitude and then direction. So we've got certain quantities that, especially if you think about in terms of just in terms of displacement or distance, if I walk a mile, it makes a difference what direction I walk in, and so we would use a vector to represent that. Or we can look at not only distance or displacement, but speed and velocity. So these are used to represent quantities that involve both the magnitude and a direction. Mathematically, there are a way for us to deal with that. Some examples or a comparison. Now, if it's just an amount, we call that a scalar quantity. A scalar just has an amount. And so typically, we would say that distance is just an amount. But in physics, when we call it a displacement, we put a direction to it. So, I'm going to drive 52 miles. But a displacement, I'm driving 52 miles. Let's do north 20 degrees east. Right, so that's a vector. I know I have a direction with that. Or we could drive at 60 miles per hour. Now that would just be a speed. If we put a direction to it, we call that a velocity. Okay, so vectors are used when we have to deal with the idea of having both the magnitude and amount and the direction we're going. So, how do we represent these? Well, the graphical way is just to use an arrow. So when we do an arrow, the length of it corresponds to the magnitude. Right? So I have, I'm drawing using some scale. So maybe a millimeter is the same as a mile, or a millimeter is a kilometer, something like that. And then we also the arrow points in the direction I'm going. So we have a direction to it. And so arrows allow us to have a length, which is our magnitude, and point in the direction of the vector. And of course, then having those components allows, and I can make right triangles and do some different things about that. So part of your next assignment will just be drawing vectors. So let's do an example here. I want to draw the vector (50 centimeters per second), so it's a velocity, north 30 degrees east. Now also, if you're taking physics, you'll find, unlike physics, that the units vary quite a bit more in this trig book, which is fine. So basically, I'm going to draw an arrow, right, that matches up this description. Generally, you can draw a coordinate plane. You know, this is north-south and east and west. We'll start the arrow at the center here. And then what angle do I draw that at?
30 degrees.
Well, 30 degrees from the north, right? So it would be an arrow like this, pointing in that direction. This angle here is 30 degrees. And we know that the magnitude corresponds to the amount of the velocity. This magnitude would correspond to 50 centimeters per second. That's the vector, right? Just that arrow. So pretty simple to draw. And one thing we're going to do then in this class here is do some basic addition of vectors with this. So we can add these vectors together. And let's talk about a couple of the properties about how you're going to add these together. Pretty simple to do that as well. Plus, for the most part, we're not going to have most of our, in this section, the vectors will make right triangles, and so we don't have to worry about that. So part 2 here is adding vectors. Yes, 3. Thank you. Okay, so the basic method to do this when you add graphically, you draw the vectors tip to tail. So you put the next vector on the tip of the first one. And then the answer goes from the beginning to the end of all the vectors you've added. Sometimes referred to as the resultant. The answer is the resultant. Is the vector. So the resultant, of course, the answer is a vector from beginning to end. So that means since the resultant, the answer is a vector, your answers will always have both a magnitude and amount. And a direction. Okay, so your answers will always be vectors. The other thing to remember, when you add vectors, you can add them in any order. So they can be added in any order. The order doesn't matter when you add vectors. So let's run through that time, I think, for one quick, easy example. I want to add, let's see, it's add, add 20 meters east, so it's a displacement, to 50 meters north. So your first step is always to draw the vectors out tip to tail. Try to draw them in proportion somewhat. So you can see that my 20 should be, less than half the length of the 50. So let's see. It doesn't matter which start the east if you want. So we got 20 east. So let's say this is 20 meters. Then where do I draw the 50 at? Tip of this one. So I go tip of this one and draw my 50 like this. So this is 50 meters. So I draw the tip to tail. I can just keep stacking them up basically, if you want to think of it that way. The answer is which vector? It goes from beginning to the end and points in the direction of the end. So this is called the resultant. There's the answer.
So we have to find the angle?
Yes, so you need to be able to describe, this is the answer. So you need to describe this vector.
You need to find the angle? This is a tangent?
Right.
Tangent?
We need the length of it and the angle.
See, when you're putting arrows on the end of those lines to make it an invalid, like you wouldn't do that, would you? Because it's not a forever line.
Well, we put arrows just to show the direction that line is, right? It's still right. It's just not. It's the arrow does not mean it goes on forever, like in geometry. It just means that that's the direction it's pointing. Describe this vector. Okay, so we need to find the magnitude and the direction, right? Well, how do we find the magnitude? Right, so we call it, let's do R, result. We know that R squared is the square root of 20 meters squared plus 50 meters squared. So R would be, who has a calculator? Yeah, and we'll just go ahead and approximate this, do not leave it exact. So square root of 20 squared plus, yeah, so 53.8 or 9, I guess. So it'll be 54 meters. That's the length of it, but we also need a direction. So I'm going to find this angle here. So we have the opposite, the adjacent. So theta is going to be the inverse tangent of 50 over 20. How much?
68.
Okay, so 68 degrees. Now the thing is, I have to find the angle from the north, right? So I need this angle here, which you said is 22 degrees, right? It's 90 minus 68. So that means that the direction would be, so it's 54 meters and it's north 22 degrees east. So that describes that vector. I've got one more thing to discuss on this section, which is another thing this book does called headings.
Called what?
Headings.
I said headaches.
So, last thing on this is the heading. And I know that this book does a lot of different ways of doing angles, and it's unfortunate.
You sound like these are really, really hard.
These aren't. No, they're not. Just there's multiple things they may list at. So, a heading basically, again, used more for navigation than anything. They'll always measure it from straight north. And they're rotated clockwise. So a little different than a lot of things we do. So they're always from the north, rotate clockwise. So their range is from 0 to 360. So anytime you're given just an angle, it's a heading. So if we want to, again, in a problem that said that it had a heading, of 120 degrees, where would we draw this?
Would it just go straight on?
Right, so
It'd be a heading. It'd be like
we start where on these headings?
north.
From the north. We rotate 120 degrees clockwise, right? So we'd start here,
Be in the fourth quadrant.
clockwise here, right? This would be 90. How many past 90 am I? 30 past 90, right? So this would be 120 degrees. So that would be a heading of 120 degrees. Start from the north, we go clockwise. Okay. So another example that how they may list this in the problems. So here's one. I have 75 miles with direction of 330 degrees.
So it's almost 360, so it's like in the fourth quadrant. And then 75. No, it's not gonna be like that.
So do the second quadrant.
Second quadrant, right? So I'm starting here, right? Rotating from here all the way around to out there, right?
And then you make that like just 75.
Yeah. And the length of this will be 75 miles.
Length of the arrow or?
Length of the vector here, right? Okay. Okay, so that's when you have headings. You have some problems with headings.